Next up for triangle congruence is angle side angle and angle angle side. First up, angle side angle. You have two angles and the included side. Remember, that's in between the set of congruent angles of one triangle are congruent to two angles and an included side of another triangle. Then the triangles are congruent. All right, so first one, we got to match them up. Angle A hooks up with angle D. Side AB matches with side DE. And angle B matches with angle E. If you have those three pieces, you can say triangle, let's go ABC, is congruent to triangle. Match up the angles now. A hooks up with D, B to E, and C to F. And just to recap, included means the side in between the angles. Do not forget that. Some proofs. In this case, we've got one given, which is kind of two givens because it says that SQ, it's splitting this angle. It's also splitting this angle right here. So we're going to have two sets of congruent angles from that bisection. First reason is always given. So we just talked about. Now the next we're going to talk about the two angles that are actually being split. It says angle RQS, make sure you mark it, is congruent to TQS, definition of angle bisector. And the other angle, angle RSQ, is congruent to TSQ, same reason, definition of angle bisector. Number 4 says that QS is congruent to QS. We're talking about things that are congruent to itself. That is your reflexive property. And 5 says, how are the triangles congruent? In this case, they're congruent by angle, side, angle. Remember, you can never, ever, ever skip an empty angle. Number 2, we have two givens. We got two sets of parallel lines on this one. So first reason is given, and we'll mark up those parallel lines. First one says JK is congruent to, or parallel to LM, and then top and bottom. JL is parallel to KM. I bet we're going to have some alternate interior angles here. Number 2, angle JKL is congruent to MLK, and sure enough, those are alternate interior angles. Number 3, angle JLK is congruent to angle MKL. Same reason, those are also alternate interior angles. Number 4, KL is congruent to KL. That's your reflexive property. And your triangles are congruent by angle, side, angle. Do not skip an empty angle. Oops. Angle, side, angle. Next page. Number 3, we have two givens. First given we'll put in the first statement. Angle BAC is congruent to angle DEC. That was given to us, and we got to mark it up. BAC to DEC. Second given, C is midpoint of AE. That's given to us. So let's talk about that one now. If C is the midpoint of AE, I know it's going to create two congruent segments. So I can say that AC is congruent to CE. We got to write that in our statement. Segment AC is congruent to segment CE. Definition of midpoints. That's it for the clues. Now is where you got to look at the diagram and figure out what else could you possibly mark congruence. And I notice I got a set of vertical angles that I can mark congruent. So then I'll say that. I'll say angle ACB is congruent to angle ECD because they are vertical angles. Last statement is what we're trying to prove. We're trying to prove triangle ABC is congruent to triangle EDC, and they are congruent by angle, side angle. All right, moving on to angle side. If two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the triangles are included. Should say congruent. That's a typo right there. All right, match them up. Angle A matches with angle D. Angle B matches with angle E. And the non-included side, side BC, is congruent to side EF. Congruency statement, I'm going to triangle ABC. That is congruent to match them up. A hooks up with D, B goes to E, and C matches with F. All right, proof practice. We have two givens. First statement, first given, YZ bisects angle WYX, and that was given to us. Now let's talk about that one. So this vertical line YZ, it bisects this top angle right here. So we know if we bisect an angle, it cuts it in half. And we got to say that in statement 2. So talk about the congruent angles. Angle WYZ is congruent to angle XYZ. Definition of angle bisector. We've got another given we can use. We can use this given. It says angle YWZ is congruent to angle YXZ. That was given. And then mark it up. YWZ to YXZ. Freebies are gone. What else can you possibly mark congruent on your diagram? I got the reflexive property. I can say this middle piece is congruent to itself. YZ is congruent to YZ. That's your reflexive property. Last statement's what we're trying to prove. Triangle WYZ is congruent to triangle XYZ, and they're congruent by angle, side. Remember, you can never, ever skip an empty angle. Angle, side. Next page. Number 5, we have 1, 2, 3 givens. First statement, use the first given. Angle ABC is congruent to angle CED. That was given. Mark up the diagram. ABC, CED. Next given, segment AB is parallel to segment CE. That's given. Mark it. AB is parallel to CE. Now, there's one thing I can do with this one. If I have some parallel lines, I don't see any alternate interior, I don't see any alternate exterior, but I do see a set of corresponding angles. I can say this angle right here is congruent to that angle right there. If I put this triangle on top of that triangle, these two angles are going to match up, hence corresponding. So now we got to say that. Angle BAC is congruent to angle ECD. They are corresponding angles. Got one more given I can use. It says C is the midpoint of AD. That's given. Let's talk about that. If I know that C is the midpoint of AD, I can say that AC is congruent to CD. So let's say that AC is congruent to CD. Definition of midpoints. Last statement's what we're trying to prove. Triangle ABC is congruent to triangle CED, and they're congruent by angle, side. Number 6, two givens. First statement, first given, PR bisects angle QRS. That's given. Let's talk about it. If PR right here bisects angle QRS, I know that this angle is going to be congruent to that angle, so I cut it in half. So say it. Angle QRP is congruent to angle SRP, definition of angle bisector. Number 3, use that next given up top. Angle PSR is congruent to angle PQR. That's given, and then we got to mark it up. PSR is congruent to PQR. Freebies are all gone. Look at the diagram, see what else you can mark up. Reflexive property right in the middle there. PR is congruent to PR, reflexive property. Last statement's what we're trying to prove. Triangle PSR is congruent to triangle PQR by angle, angle, side. Last proof for angle, angle, side. We have 2 givens. First one says LG is parallel to JM. Let's mark it. LG is parallel to LM. I'm going to have some alternate interiors here, so let's find the set here. I'm going to use, or say this angle is congruent to that angle because they're alternate interior. So angle G is congruent to angle J because they're alternate interior angles. Number 3, use that second given. H is midpoint of LM. Reason given. All right, so if H is the midpoint of LM, I know that LH is congruent to HM. So LH is congruent to HM, definition of midpoint. Freebies are all gone. Look at the diagram to figure out what else you can mark congruent. In this case, I've got a set of vertical angles that I can mark congruent. So we'll say that angle GHL is congruent to angle JHM, vertical angles. Last statements what we're trying to prove. Triangle LGH was congruent to triangle MJH by angle, angle, side. Next page. Last page. Last section talks about HL, guys. This was the last one we had on your list. This only works for right triangles, remember. Goes on to say, if the hypotenuse and a leg of one triangle is congruent to the hypotenuse and one leg of another triangle, then the triangles are congruent. All right. So the hypotenuse, let's see, we got BC is congruent to EF. The legs they used, they said AB is congruent to DE. Congruency statement, first guy any order, I'm going to go ABC. A matches with D, B hooks up with E, and C matches with F. And just to recap, guys, remember the hypotenuse is the side opposite the right angle. A leg is the side adjacent to the right triangle. So hypotenuse across the right angle, a leg touches the right angle. 2 proofs. We have 2 givens. First one says, hey, this triangle is a right triangle, and this guy's a right triangle. Reason given. Next one is also given to us. It says ML is congruent to MN. That was given. Freebies are gone. But number 3 is saying, hey, MP is congruent to itself. MP, that's your reflexive property. Well, how are the triangles congruent? Well, they are congruent by, they have one set of legs that are congruent, and they have one set of hypotenuse that are congruent. So these are congruent by HL, hypotenuse leg. Last one. 1, 2, 3 givens. First statement, first given. Triangle WVX is congruent to triangle YZX. That's given. Can't do much with that one just yet, but we know we've got a right angle somewhere in these triangles. I'm guessing it's right here, but we'll see. Next given says that WV is congruent to YZ. That's given to us. Make sure we mark it up. WV congruent to YZ. Number 3 says that X is the midpoint. This is your last freebie of WY. That's given. Talk about it. If X is a midpoint of WY, then I know that WX is congruent to XY. And we'll say that. WX is congruent to XY, definition of midpoint. Now, real quick, go back up to the diagram. Let's mark those 90s. Angle V was a 90, and angle Z is a 90. Last statement's what we're trying to prove. Triangle WVX is congruent to triangle YZX by, well, the right triangles. I have one set of legs that are congruent, and I have the hypotenuse for each triangle that are congruent as well. These are congruent by HL. That's it for that lesson.